What's up, everybody? Mr. Murray here, Mr. Murray's Mathland, and today we are looking at dividing polynomials using synthetic division. And if you've done long division, you know synthetic division can be a lot quicker, or maybe you don't know about synthetic division and you're looking for a faster way. And it certainly is, except you can only use synthetic division in certain scenarios, and that's if your divisor is 1x to the first plus or minus some constant. So if that's the case, then you're free to use synthetic division. So if that divisor has an x squared or a higher degree other than 1, then you have to use long division, unless there's some crazy, cool factoring you can do to break it down. And you can, if it's, say, 2x to the first or 3x to the first, you can use synthetic division, but not until you make it 1. So you'd have to divide everything by 3. For example, include, all of this stuff. And sometimes that's worth it and that's kind of cool. But just know if you want to use synthetic division, you want to have it in this format where it's 1x to the first plus or minus some constant in your divisor. Okay, so now actually doing synthetic division here. So if you've never done it before, there's usually two parts to it. One, you do some kind of a box here, and sometimes people make a little box out here, and there's a couple of things to this to just be careful with. One is if you're dividing by x plus 2, you actually want to take the solution or the 0 to that, which is -2, and that's the number you want to put outside here. Sometimes people don't make a box, or they just kind of have it sitting outside of that. But out there is -2. And now for your dividend, notice we're dividing into 8x to the fourth, 11x cubed plus x minus 3. Notice how there was no x squared term. And this is ultra crucial with synthetic division here, because you're just going to use the coefficients for these terms. And so normally I wouldn't bother to do this once you're in the swing of it. But I'm going to make a little column. If your highest degree is 4, like it is in this case, or whatever your highest degree is, you have to start with that coefficient. And then you want a column for every degree less than that. So I'll need a column for x cubed, I'll need a column for x squared, I'll need a column for x to the first, and I'll need a column for the constants. And now I'm going to just grab the coefficients from each of those terms. So for my x to the fourths in this problem, I'm dividing into 8. For my x cubes, there's a positive 11. So you might not write the positive sign, you might just write 11, personal preference. For x squared, I didn't have any x squared, so I need to have a 0 placeholder here. For my x's, that's plus x, so that's really a coefficient of positive 1. And for my constant, I have a -3. Okay, so if you haven't done synthetic division before, there are a couple of little mistakes to watch out for, or potential pitfalls, and that was one of them. Certainly that you want to put -2 on the outside if you're dividing by x plus 2. Kids usually just get into the habit of like taking the opposite of what they see here and putting it out here. No big deal once you get used to that. And then what you're dividing into, make sure you have a column and just use those coefficients. And if you need any 0 placeholders, if you're skipping any terms, just make sure you use that. Okay, so normally I wouldn't even bother writing these little titles at the top of the columns. I would just go right into the 8, 11, 0, 1, -3. But okay, now how to actually do it. You take whatever is your first coefficient, in this case 8, and you start by writing that underneath the line here. I probably left a lot of space here, maybe too much, but who cares? You're going to see as we get this going. And now here's the process. You take whatever that number is down here and you multiply it by what's in this little box. So 8 times -2 is -16. And then you write that in the next column below whatever coefficient came from your dividend. And now you combine those two numbers. So 11 and negative 16 combine to give you negative 5. So you're just adding them together, if you will. I like to just say combining them, but gives you negative 5, and you write that below. And now you repeat that process there that we just did. So negative 5 times negative 2 gives us positive 10, and we write that in the next column. So 0 plus 10 is positive 10, and then repeat that again. Positive 10 times negative 2 gives us negative 20, so I'm going to write that in the next column. And 1 minus 20 combines to give us negative 19, and then negative 19 times negative 2 gives us positive 38. And right here at the very end, that's going to give us positive 35. What you get at the very end is always your remainder. So in this case, I have a remainder of positive 35. And here's how you take this and turn it into your answer. Is if you think about it, you were dividing x to the first into x to the fourth. So you're going to get something that's x to the third when you do that. And that's really what happens here, is that these are all the coefficients of those terms, but you start with 1 degree lower than your dividend. So this is 8x to the third, and this negative 5 that comes after it represents negative 5x squared, and you just count down from there. And then I have 10x minus 19, and just like when you're dividing with long division, plus whatever remainder divided by your divisor. So our divisor, remember, was x plus 2. That's what we were really dividing by this whole time. And there's your final answer. Pretty easy, especially if you get the routine down. I mean, I tried to go slowly and explain things, but if you know what you're doing, you can really fly through that. And if you are familiar with long division, you know that basically changing the sign right here from 2 to negative 2, doing that one sign change there allows you to just combine these, so you don't have to do the divide, multiply, and subtract step. So you just combine from doing that one sign change at the beginning, and you're good to go. Of course, if you ever doubt your synthetic division, you can just use long division, always. So here's one more example, and I just presented the problem in a slightly different way, but hopefully you know this is division, of course. That's that x cubed polynomial on top divided by x minus 4. So that is 1x to the first, so I can use synthetic division on it. So I'm going to make my little box, and now what goes out in front, if I see minus 4 there, that means I'm going to have positive 4 there. And you can make a little pocket for it if you like. So just remember that you were dividing by x minus 4, so you always take the opposite of that constant, or the 0, the solution, if you will. And now I'm going to put my coefficients here. So my highest degree is 3. I have x cubed. Do I need any 0 placeholders? I've got x squared, I've got x to the first, and I've got a constant. So I have no 0 placeholders. It's all in order. So I'm just going to grab those coefficients just as they are. 3, negative 14, positive 13, negative 20. And then I'm going to start that. Just here's how you get started, is you bring down what's up there first. That's going to be the beginning of your answer, your quotient. And then you start with 3, whatever's down there, times whatever's in that little box. So 3 times 4 is positive 12. Then you combine. Negative 14 plus 12 is negative 2. And you just repeat that. Negative 2 times 4 is negative 8. Combine those. 13 minus 8, positive 5. Positive 5 times 4 is positive 20. And what we get there is we actually get a remainder of 0. And whenever I get a remainder of 0, I put a little smiley face in it because it's a good thing. It means it went in evenly, which really means that x minus 4 is a factor of this, right? That's when things go in evenly, there's no remainder. That means they're a factor. And that's generally a good thing in math. So our final quotient is going to be 3x to the, and we divide it into x cubed. So our quotient is going to be 1 degree lower than that, 3x squared minus 2x plus 5. And with no remainder, it went in evenly. So very nice there. And that's that. And if x minus 4 is a factor, that means that x equals 4 is a 0 of this polynomial. If I were to graph it, I know it would be hitting the x-axis at 4, but that's really another video that's kind of builds off this, but I'll just give you a little teaser of where we're going with this. And so that's that. Hopefully synthetic division seems like a piece of cake to you, because it really is once you get the hang of it. So if you have any questions, give me a shout. But otherwise, keep working hard and hang in there, kids.